In lesson 7.3, we're going to look at equations with the distributive property. In the first half of this lesson for 7.3a, we're going to use the distributive property on both sides of the equal sign. And our goal for this lesson is to use the distributive property to eliminate what are called grouping symbols, then solve equations. One thing I do want to say about this lesson is that in order to be successful with this lesson, we have to have a good grasp on what we need to do in order to solve the equations that we found in 7.1 and in 7.2. So we need to be comfortable with those types of equations. If we're not comfortable with the equations from 7.1 and 7.2, we need to schedule some time to get in to conference so that we can go over those problems and make sure that we have a good understanding of how to solve them before we proceed with 7.3. Now in the goal for this lesson, I talked about grouping symbols. And there are three main types of grouping symbols. The most common one that you'll see in these types of problems are what are going to be called parentheses. So parentheses are just the parentheses that you've grown up seeing. We also have what are called brackets. And that are those symbols that you see there in red. Now just because it's March Madness doesn't mean that it's a championship bracket or anything like that. It's just those symbols there. And then finally we have what are called braces. And those are what we see there in green. So again, parentheses, brackets, and braces. Those are the three main types of grouping symbols. For the most part, we're only going to be using parentheses. But instead of, if there is a more complex problem that requires some distribution, you might see parentheses inside brackets, and you might then see the brackets inside of braces. And what we do is we work from the inside out when we're doing our distribution. So if there's parentheses inside the brackets, we simplify the parentheses first. And then if there's brackets inside of braces, we simplify the brackets next. And then finally, we simplify what's inside the braces. That is just order of operation. And I believe that you've done distribution in the past, especially, again, going back to order of operations. But for this lesson, we're going to take some time to go over how distribution plays a role in solving equations that might have variables on both sides. So let's go ahead and take a look at some examples of what this might look like. Actually, before we get to some examples, I want to go ahead and lay out some general kind of guidelines or steps that we can follow when we're solving some of these more complex equations. So generally speaking, what we want to do when we're solving an equation is we want to completely simplify each side of the equal sign individually before we move on to using inverse operations to put our variable terms on one side of the equal sign and our constant terms on the other side of the equal sign. Let me write those steps out so that it hopefully looks a little bit clearer. So, written out, the steps for solving equations, our first step that we're going to take is we want to simplify both sides of the equal sign. And we do this by using distribution, and then we also want to combine like terms. We haven't talked about combining like terms, but when we're talking through some examples, you'll hear me use that phrase quite a bit. So we want to distribute and then combine like terms, and then only after each side of the equal sign is completely simplified. So that means we have a variable term and a constant term, and those are the only things that remain on either side of the equal sign. Once our equation looks like that, then we use inverse operations to move variable terms and constant terms to opposite sides. Alright, let's take a look at some examples of what this is going to look like. For our first example, we have 3 times the quantity x minus 5 plus 1 is equal to 2 plus x. So when I say times the quantity, that's my way of referring to the grouping symbols there. 3 times the quantity x plus x minus 5. Okay? Now, what we want to do here is we need to simplify both sides of our equal sign first. We can clearly see, first of all, because we have parentheses, we can clearly see that on the left side that we have some simplifying to do. But when we take a look at the right side, we have 2 plus x. We have a constant term, and we have a variable term. That's it. There's nothing we can do to simplify this right side of the equal sign. So we're going to focus primarily, at least for this example, just on the left side. Now for our first step, in order to simplify the left side, we need to distribute. We need to get rid of those grouping symbols by distributing. So I'm going to distribute this 3 into the parentheses. So I have 3 times x gives me 3x. Bring down my minus sign. 3 times 5 gives me 15. So that's essentially what distribution means. We're taking a term that's outside of the parentheses, being multiplied by the parentheses, and we multiply that term by each part inside the parentheses. Now, a common mistake that students will make is if there's a plus sign here, they'll still think that they need to distribute. But we only distribute when there's multiplication. If there was a plus sign there, we would not want to distribute that. All right, so we've distributed the 3 into the parentheses. Now we bring down the rest of our problem, making sure we keep our equal signs aligned. Now when we look at that left side, there's 3 parts to it still. There's 3 terms. I have a 3x, I have a minus 15, and I have a plus 1. So this is not simplified all the way. I need to combine my like terms. Now, my like terms are either going to be variable terms or they're going to be constant terms. When I look at this 3x here, there are no more variable terms on the left side of the equal sign. So there's nothing I can do to combine that 3x with anything. But then when I look at this minus 15 and this plus 1, those are both constant terms, and I can combine those. I'm not going to move them across the equal sign or anything like that until after I've completely simplified the left side of the equal sign. So in order to do that, I'm just going to bring down my 3x, and then I simply take negative 15 plus 1. Don't overthink it. Negative 15 plus 1. We start at negative 15 on the number line, add 1 by moving 1 to the right, and we get minus 14. Okay, negative 15 plus 1 equals negative 14. That's where that came from. Then I bring down my equal sign and the rest of my equation. Now I look at my equation again. My first step up here, I did my distribution. Second step here, I did combine like terms. Now I'm left with a variable term and a constant term on the left, and a variable term and a constant term on the right. So there's nothing more I can do to simplify either side of this equation. Once I'm here, now I want to go ahead and start moving things across the equal sign. I do not start moving things across the equal sign until I have completely simplified both sides of the equal sign. So, moving things around, I'm going to put a 1 in front of this x, and now I look at my variable terms. 3x here, 1x here. 1x is less than 3x, so I'm going to move my 1x using inverse operations. I have a plus sign here, so in order to get rid of that plus 1x, I'm going to subtract 1x from both sides. These will cancel. On the left side here, I have 3x minus 1x. Gives me 2x. Bring down my minus 14. And keep my equal signs aligned. I have 2 on the right side. Now, one more step in order to move my constant terms over to the right side. I'm going to add 14. The reason I add 14 is because I have this minus sign right here. If this was a plus sign, I would use the opposite term, or the inverse operation, and I would subtract. But because this is a minus sign, I'm going to add 14 to both sides. And I get 2x equals 16. There we go. 2x equals 16. One more step. One more inverse operation in order to get this variable term all by itself. So I'm going to divide both sides by 2. The 2's will cancel here to get x equals 8. It's a lot of work. There's a lot of keeping track of things. But if you just keep in mind, Simplify both sides of the equal sign first, before I start doing anything across the equal sign. You'll have much more success with these problems. Another thing I want to point out, if you take a look at my equal signs, they're all in a nice, even column going straight up and down. Now I know some previous math teachers like to put like a slash down the line of the equal sign or something like that. I'm not a big fan of that. If that helps you keep track of your work and help you stay organized, feel free to do so. I'm not a big fan of it, but if that's what you want to do to help you make sure that you're keeping your equal signs aligned, go ahead, feel free to do so. So again, for this problem, we got x equals 8. Let's take a look at a couple more where we are going to have to distribute, then combine like terms before we can actually solve. For our second example, we have negative 3 plus y minus 5 is equal to negative 9 times the quantity y plus 2. We can see that both sides require some simplification. We need to simplify both sides. Let's start with the distribution on the right side. So I'm going to take this negative 9. I don't just distribute the 9, I have to distribute the negative sign with it. So I'm going to distribute the negative 9 into the parentheses, to the y, and to the plus 2. So on the left side, I'm just going to copy down what I have there. Negative 3 plus y minus 5 is equal to. Now when I distribute the negative 9 into the y plus 2, I'm going to get negative 9y minus 18. In the past, I've seen a lot of students forget about this negative sign. They'll bring it down to here, but they won't distribute the negative to the positive 2 as well. So they'll end up with negative 9y plus 18, and that obviously will throw the problem in your answer off. So you need to make sure that if there's a negative sign in front of the number that you're distributing, you need to bring that negative sign along for the distribution. Now looking at the right side, negative 9y minus 18. I have my variable term and I have my constant term. Nothing more I can do to simplify what's on the right side, so I go back to take a look at the left side again. And on the left side, negative 3, it's a constant term. Plus y is a variable term. Negative 5 is another constant term. I hope I said that right. So I have constant, variable, constant. If you want to put underlines under your terms so that you can better able to identify your constant terms and your variable terms, feel free to do so. Not something you have to do. I like doing that, especially when I'm introducing how to do this, just so that students are able to more easily see what terms they need to combine. So, negative 3 and minus 5, they both have a single red line underneath them, so I'm going to combine those. That means negative 3, I'm going to ignore this plus y. I'm just going to say in my head, negative 3 minus 5. Negative 3 minus 5 will give me negative 8, and I bring down my plus y. Keep my equal signs aligned, and I bring down what I have over on the right side. At this point in the problem, on the left side, I have a constant and a variable. On the right side, I have a variable and a constant. So there is now nothing more I can do to simplify either side of the equal sign. So I'm going to start moving things around. Let's go ahead and put a 1 in front of this variable term. So now I'm going to compare my variable term coefficients. I have a plus 1 here and a negative 9 here, or a minus 9. Positive 1 is greater than negative 9, so I'm going to move my 9y to the other side of the equal sign. Using inverse operations, meaning since it's a negative 9y, I'm going to add 9y to both sides. It's going to cause these to cancel, and I have negative 8 plus 10y equals negative 18. My variable term is now on the left side, and I want to move my constant terms over to the right. So that means I need to get rid of this negative 8. So I'm going to add 8 to both sides. These will cancel. So I have 10y is equal to negative 18 plus 8, gives me negative 10. Final step, get rid of my coefficient by dividing by it, dividing both sides by 10. 10's cancel here, giving me y equals negative 1. I know that we're kind of at our time limit right now, but I still want to take a look at one more problem so that we can just get a better grasp on how we need to go about using our distribution and then combining like terms before we can go ahead and start moving things across the equal sign. So one more example that we're going to look at. Final example, we have 7 times the quantity 2x plus 3 minus 11 equals negative 5 times the quantity x plus 4 minus 8. First step is going to be to distribute to get rid of our grouping symbols, and we can do distribution on both sides of the equal sign at the same time. So I'm going to start off on the left side, distributing my 7 into my 2x plus 3, giving me 14x plus 21, and then I bring down the minus 11, bring down my equal sign, and now I can do my distribution on the right side where I distribute the negative 5, not just 5, I distribute the negative 5. Distribute the negative 5 to the x and to the plus 4, giving me negative 5x minus 20, and I bring down my minus 8. Now, I'm going to go ahead and identify what my like terms are. So I have 14x as my variable term, 21 and minus 11 as my constant terms. On the right side, minus 5x is my variable term, and then negative 20 minus 8 are my constant terms. So there's nothing that I can do to combine my variable terms on either side, so I'm just going to bring those down, but I will combine my constant terms on both sides. I'm going to take 21 minus 11 on the left side and negative 20 minus 8 on the right side. So when I do that, I have 14x. 21 minus 11 gives me 10. Keep my equal signs aligned. Bring down the negative 5x on the right side. Then I combine negative 20 minus 8. Gives me negative 28. Now I've completely simplified both sides of the equal sign. There's nothing more I can do to simplify either the left side or the right side because I'm left with just a variable term and a constant term on the left side and a variable term and a constant term on the right side. So there's nothing more I can do to simplify either side of this equal sign. Now that I've done all the simplification I can do, now I start moving things across the equal sign. And I start by looking at my variable terms. Positive 14 for a coefficient here, minus or negative 5 for my coefficient over here. So I want to move my smaller coefficient. So I'm going to add 5x to both sides. That'll cause these to cancel on the right. And I have 19x. Bring down the plus 10. Keep my equal sign aligned. And I bring down my negative 28. Don't lose track of this minus sign. I've seen a lot of students get points taken off on these problems just because they forget about a minus sign there. Next thing I want to do, use inverse operations of my variable or my constant terms, meaning I'm going to subtract 10 from both sides. So I have 19x equals negative 38. Scroll up a bit. And finally, inverse of multiplication means I'm going to divide both sides by 19, divide both sides by the the coefficient. 19's cancel. You get x equals -2. All right. They're not always going to work out so nice and neat as x equals -2 or something like that. However, in this problem it did. What I want you guys to do, make sure that you look back over your notes, write down any parts of the notes where you might have any questions or comments so that we can go over those together as a class. Before I close out the video, I just wanted to show these steps one more time so that we can see again. When we're simplifying, we distribute first, then combine like terms, then use inverse operations in order to move variable terms and constant terms to opposite sides. Now at this point, I hope that you're able to use the distributive property to eliminate grouping symbols, then solve the equation. Any questions, make sure to bring those up in class.